Algebra 1, Chapter 2, Section 5, Solving Equations Involving Absolute Value. So, the absolute value is a function, and basically what it does is it tells you how far away a number is from 0 on the number line. So if I just sketch out a quick little number line, I'm not lining it up with the graph paper at all, but if you have a point on it, let's say I put a green dot here at positive 3, the symbol is 2 vertical bars, and it's asking the question, how far is that point from 0? And it is 3 spots from 0, so it returns 3. If we put another dot, let's say at negative 4, when I see the absolute value of negative 4, it's asking how far away from 0 is that point on the number line. And it's 1, 2, 3, 4. So even though it's a negative value, the distance from 0 is positive. So that's the main rule here is whatever's inside the absolute value, make it positive. Don't change the sign, just make it positive. If it's already positive, leave it alone. If it's negative, make it positive. So that's the idea behind what an absolute value is. For the first example here, we're going to evaluate an expression using the absolute value. So you can see I've got the absolute value of m plus 6, and whatever that absolute value is, minus 14, and we want to let m equal 4. Now a quick note I want to put here, you can see I kind of spaced the 6 and the absolute value bar apart. One thing you have to be careful with is when you write something like this, if you write it too compact, it ends up looking like 1m plus 61. So when you make the absolute value bars, make them larger than the line of everything else that you're writing. So that way it's really clear. It's like a grouping symbol. It is bigger. It will prevent little errors when you're working. So I'm going to plug that value in there. Plug in 4 for m, plus 6 minus 14. 4 plus 6 is 10. Absolute value of 10 minus 14, and we get 10 minus 14, or negative 4. Not too tough with that one. Just plugging it in and seeing what the value is. Didn't even have to change the sign on that. All right. Next step. Whenever we solve an absolute inequality, because it has that property where whatever's inside makes it positive, there's two. If you have something really simple, like the absolute value of x equals 2, that's going to create two equations. It's going to create a positive version, where you just drop the absolute value and set it equal to 2, or the negative version, where the x stays the same, everything inside the absolute value bar, and what is on the other side of the equal sign becomes negative. So then you have two separate equations that you're solving for each one of these. Now what does that look like? And, a big thing here is the absolute value has to be isolated. If it has anything attached to it, either through multiplication or through addition or subtraction, you have to move and rearrange everything so that the absolute value is all by itself before you can split it into 2. You can't just split it right away. So in example 2 here, we're trying to solve some absolute value equations. I see that my absolute value bars are isolated, so that's going to give me f plus 5 equals 17 for the positive part, and f plus 5 equals negative 17 for the negative part. And now I'm going to solve each one of those equations just like it's a normal 1 or 2 step equation. So f can equal 12, or f can equal negative 22. Now, one way you might see this answer also written is f equals the set negative 22 and 12. You're answering the question this way by stating it as a set of values. So we use the set brackets, the little curlicue, like it's like you're drawing a bird, but it's sideways, right? So that's another way you can see the answer. I'm perfectly fine with just boxing the two answers individually, but in the back of the book, you'll probably see it something like this alternate method here. All right, now, here's a very important thing. Here, the absolute value of b minus 1 equals negative 3. Whenever you have an absolute value, its result is always positive. But in this case, it gave us a negative value for the absolute value. This should immediately tell you that there is no solution. As soon as that absolute value is isolated and it equals a negative, no solution. And you can write it as no solution, or you can write it as the empty set. Either one of those works just fine.